I bet you didn't know how crucial testing is in our everyday lives. Once upon a time there was a curious child who loved building towers with colorful wooden blocks. Every day they would stack the blocks higher and higher, wondering just how tall their tower could grow before it tumbled down. It was a game of balance and stability. In a way, this child's game mirrors the work of engineers. These modern-day builders constantly test the limits of their creations, pushing them to see how much they can endure. From bridges that span great rivers to airplanes that soar through the skies, and even the tallest skyscrapers that touch the clouds, engineers must ensure these structures are strong and reliable. This is where the magic of testing comes into play. Testing is the hero of our story, a crucial step in the engineering process that ensures everything we build can withstand the trials of time and use. Just like a doctor gives us a checkup, engineers give their designs a thorough examination. They inspect, test, and validate to ensure everything is in perfect working order. They push, pull, and prod their creations, testing their limits to improve their strength and durability. This rigorous testing ensures that everything we use is safe and reliable. Safety is always the top priority in this tale. Without these tests, we wouldn't know if our buildings could withstand the fury of an earthquake or other natural disasters, or if our cars could protect us in a crash. Crash tests are vital to enhancing vehicle safety features. Testing is essential across many fields, from construction and manufacturing to aerospace and medicine. Each field presents its own unique challenges and requirements. Through testing, we avoid accidents, improve designs, and innovate new solutions to old problems, and so, we ensure our world is built to last. Through the power of testing, our creations stand the test of time, serving us well into the future, and that, dear listener, is how we make sure things don't break. Once upon a time in a bustling laboratory, a group of curious scientists had a peculiar mission. They needed to break things to make them stronger. This fascinating process was known as destructive testing. Picture this. A simple rubber band being stretched to its limit until it snaps. In that moment, the magic of destructive testing unfolds. One of the heroes of this story is tensile testing. Imagine taking a sturdy piece of metal and pulling it from both ends until it gives way. This reveals the strength hidden within, showing us how much force it can endure. Another thrilling chapter is impact testing, where a heavy weight is dropped to test resilience. Though it may seem like a waste, this method is crucial for discovery. By intentionally breaking materials, we uncover their secrets and learn how to make them better. And so, the story of destructive testing continues, driving innovation forward. Imagine a world where we break things on purpose. That's the essence of destructive testing. On one hand, it's like a detective story. We get clear, undeniable evidence. When something breaks, we uncover its secrets, how much stress it could endure before giving in. This knowledge is a treasure trove for designing safe and reliable products, but every story has its twists. Destructive testing has its downsides too. The most glaring one? It destroys the very thing we're testing. This means no second chances with the same product, and it can get pricey if we need to test many samples. Yet, despite these hurdles, destructive testing is a cornerstone in many industries. It offers invaluable insights that help us craft better, safer products, ensuring the story ends on a high note. Imagine a world where we could peek inside objects without causing any harm. This is the magic of non-destructive testing. Picture having X-ray vision, allowing you to see inside an object and spot any hidden flaws or weaknesses. One fascinating method is ultrasonic testing, where sound waves reveal cracks or voids in materials. It's similar to how doctors use ultrasound to see a baby inside the womb. Another captivating technique is radiographic testing, using X-rays or gamma rays to capture images of an object's internal structure. With non-destructive testing, we can explore and inspect objects without causing any damage, making it an invaluable tool across many industries. Welcome to Section 5, where we dive into the fascinating world of non-destructive testing. Let's explore its strengths and weaknesses. Imagine a world where you can inspect the integrity of an object without leaving a single scratch. That's the magic of non-destructive testing. Picture a technician using a sophisticated device, gently scanning the surface, ensuring everything is in perfect condition without causing any harm. This technique is a lifesaver for critical components like airplane wings or pipelines, where even the slightest damage could be catastrophic. And the best part? These tests can be performed right on site, saving time and resources. Imagine not having to halt production or dismantle machinery. Non-destructive testing keeps everything running smoothly. However, like all good stories, there's a twist. Non-destructive testing isn't always as precise as its destructive counterpart. It might miss tiny flaws, and the accuracy can depend heavily on the operator's expertise. Despite these challenges, non-destructive testing remains a crucial tool, ensuring safety and quality across various industries. Once upon a time in the world of engineering, a great debate raged on: destructive versus non-destructive testing. Which one wins? Imagine a bustling lab where engineers and scientists are constantly faced with a crucial decision. They ponder, which testing method should we use today? The answer isn't always straightforward. Each method, like a character in a story, has its own strengths and weaknesses. Picture this. If you need to know the exact strength of a material, you might have to break it. Destructive testing, though harsh, reveals the material's true limits. But what if the component is critical and must remain intact? Enter non-destructive testing, the hero that inspects without causing harm. Imagine testing a chair's durability. To find out how much weight it can hold, you might have to break it. This is the essence of destructive testing. Now think about inspecting a bridge for cracks. You wouldn't want to break the bridge, right? Non-destructive testing methods like ultrasound or X-rays come to the rescue. In the end, both methods have their roles to play. The key is understanding the context and requirements of the test to choose the right hero for the job. And so, the debate continues with each method shining in its own light. Welcome to Section 7, where we uncover the secrets of choosing the right test for the right job. Imagine you're in a workshop, surrounded by an array of tools. Each tool has a purpose, just like each testing method. You wouldn't grab a hammer to tighten a screw, right? It's all about using the right tool for the task at hand. Similarly, in the world of testing, each method shines in its own unique way. Destructive testing, for instance, is the hero in research and development, helping to unveil the mysteries of new materials and perfect designs. It also plays a crucial role in quality control, ensuring that every material and product stands up to the highest standards. On the other hand, non-destructive testing is the guardian of industries like aerospace, automotive, and construction, inspecting critical components without causing harm. By mastering the strengths and understanding the limitations of each method, engineers can craft the perfect strategy for their unique challenges. Chapter 8. A journey through testing from cars to rockets. Imagine a world where every car, every rocket, and every building stands as a testament to human ingenuity and safety. This world is made possible through the relentless pursuit of testing. From the vehicles that transport us to the rockets that venture into the cosmos, testing ensures that every product meets the highest standards of performance and safety. Picture a car hurtling towards a barrier at breakneck speed. This is no accident, it's a meticulously planned crash test. Engineers simulate real-world collisions to gather crucial data, helping them understand how vehicles behave under extreme conditions. As the car collides with the barrier, sensors capture every detail. Engineers analyze the aftermath, studying how well the vehicle protects its occupants. This data drives innovations, making our cars safer with each new model. Now shift your gaze to the skies. In aerospace, the stakes are even higher. Non-destructive testing methods allow engineers to inspect aircraft engines and fuselages for microscopic cracks. These tiny imperfections, if left unchecked, could lead to catastrophic failures. On the ground, the construction industry relies on rigorous testing to ensure the strength and durability of our built environment. Engineers conduct a variety of tests to assess materials and structural integrity, ensuring that buildings, bridges, and other structures can withstand the test of time and natural forces. From the cars we drive to the planes we fly in, and even the rockets that explore the final frontier, testing is the unsung hero. It ensures our safety and propels technological advancements. In every industry, rigorous testing protocols are the backbone of innovation and safety, making our modern world possible. Welcome to Section 9, where we journey into the future of testing, smarter and more automated. Imagine a world where testing evolves as rapidly as technology itself. New technologies are transforming testing, making it faster, smarter, and more efficient. One of the most thrilling advancements is the integration of artificial intelligence. Picture AI-powered systems analyzing data from sensors and cameras, detecting defects and anomalies that human eyes might miss. Another groundbreaking trend is the rise of automation. Envision robots and automated systems conducting tests with speed and precision, allowing engineers to tackle more complex challenges. These technological advancements promise a future where our world is safer and more reliable than ever before. Once upon a time in the world of engineering, safety and quality were the heroes of our story. These heroes embarked on a journey through the realm of testing, where every product and structure was put to the test. They discovered that testing was the key to ensuring the safety and reliability of everything we use daily, from bridges to toys. Our heroes explored two powerful allies in their quest: destructive testing and non-destructive testing. Each ally had its own unique strengths and weaknesses, contributing to the overall mission. They learned that testing was all about asking the right questions, pushing boundaries, and learning from both triumphs and setbacks. By embracing the spirit of testing, they could innovate, create wonders, and make the world a safer, more reliable place. So next time you see a bridge, a car, or even a toy, remember the unsung heroes of testing who made it all possible. If you enjoyed this tale, don't forget to like, comment, and subscribe for more stories about the fascinating world of testing. And don't forget to share this video with your friends to spread the word about the importance of testing.